So far the table has had a fixed size. Now let's see what happens when it fills up and how the table grows itself. We call this rehashing. When alpha, which is n over m, climbs too high, the table doubles its bucket count and replaces every key. Look at the old table. It has 4 buckets and 4 items, so alpha is 1.0. That is over the 0.75 threshold, so it is time to grow. The new table has 8 buckets. Every key is hashed again into the bigger table, so alpha drops to 0.5. With more room, chains and probes stay short again. Notice the keys move. Banana was at slot 0 in the old table, and now it hashes to slot 4. Apple moves too, from slot 1 to slot 5. The bigger table means a new home for most keys. Now this is the chaining version. First we allocate a fresh bucket array with calloc, sized for the new bucket count. Calloc also zeroes it, so every bucket starts empty. We walk every old bucket, one by one. For each bucket, we follow its chain node by node. For each node, we first save p arrow next into a local called next. We do this before we relink, so we do not lose the rest of the chain. Then we compute the node's new bucket with hash of its key and the new size. We replace the node. We do not allocate a new one. We splice the node into the front of its new bucket. We point p arrow next at the current head, then make the node the new head. When every node has moved, we free the old bucket array and point the table at the new one with its new size. This is the same amortized argument as Chapter 3's array doubling. A rare big O of n rehash keeps insert big O of 1 on average. Same shape, new structure.